All right, this is a video on identifying patterns on a hundreds chart. Okay. So this right here is a hundreds chart. You can see it goes from 1 to 100. And what I want you to do is I want you to look for patterns and then tell me what those patterns are. Now, there's no right or wrong answer to this, so just try your best and then try to explain your thinking. All right, so here's some example strategies and vocabulary used to find a few patterns on the hundreds chart. Okay. The vocabulary that was used was row, horizontal, column, vertical, diagonal, multiples, skip counting, and digits. Okay. So there are rows. Rows are horizontal. So this is a horizontal line right here. And these chairs are in rows. And when you sit in bleachers, you're usually sitting in rows. Or if you go to a movie theater, you sit in rows. Okay. This is a column. This column is vertical. We have columns in math. We call them in a table. Sometimes you have columns. And columns are vertical. This line right here is a vertical line. Okay. Diagonals are slanted. This line right here is a slanted line, so we call it a diagonal. These are all diagonals, these white lines here. Multiples right here is just a fancy word for skip counting. If you want to find your multiples of 5, the multiples of 5 would be 5, 10, 15, 20. Okay, so it's just another word for skip counting. And digits are the building blocks of numbers. If I had some tiles with digits on them, and I like to think of numbers as made of tiles. So here are all the digits that we have in our number system, 0 through 9. Whoops, I forgot 6. Upside down, 8, 9. All right. So with these building blocks or these tiles, I can make any number I want. So these are all digits. So if I take a number 12, this is the number 12. It has the digit 1 and 2. So you can see how the 1 and the 2 are building blocks to the number 12. We call this a 2-digit number. If I had this number here, 345, 345 has 3 digits, a 3, a 4, and a 5. And we would call 345 a 3-digit number. So digits are just the building blocks of numbers. Okay. All right, here are some of the examples that I got from students. One student noticed a pattern with the rows. So here's a row. And they noticed that if you started at 1 and you added 1, so if I took 1 and added 1, they got 2. And if you got 2 and added 1 more, you got 3, and so forth. So they wrote, in rows, moving from left to right, the numbers increased by 1. Another student saw columns. And here's one of the columns they so happened to circle. And they noticed if they started at the top and then went down 1, they noticed if they just added 10 to that number, they got 20. If they took 20 and added 10, they got 30. So they wrote, in columns, moving from top to bottom, the numbers increased by 10. Another student circled this right here, and they noticed an interesting pattern. They said, look it, this is a 1, 1, this is a 2, 2, this is a 3, 3, this is a 4, 4, this is a 5, 5, this is a 6, 6, and so forth. So they said, in a certain diagonal, each of the numbers were made up of the same 2 digits, 9, 9, 8, 8, and so forth. So that was nice too. Okay, now those were just examples of some of the patterns people saw, and there's no one that's better or less than the other. They're all great observations. Now, the next question for you is, what pattern is this? Now, obviously there's a million different ways to describe how you got your pattern, but after you get your pattern, then I'd like you to answer this question. Would your answer be different if you use numbers? Okay, I'm going to give you some time to think about that. All right. Here are some answers that I got. One person said, oh, the pattern is 2 not shaded, 1 shaded, 2 not shaded, 1 shaded, 2 not shaded, 1 shaded. And then they said, well, their answer would be different. They put numbers because they were dealing with shaded and not shaded, not numerals. Another person decided to try something else. They put numbers in it, and it looks like they're skip counting by 2s. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, and so forth. And they were able to finish the whole pattern using numbers. And they said, oh, well, the rows are made by skip counting by 2s, which made sense. But they said, they then looked at the shaded boxes, and then they said, the shaded boxes are multiples of 6. And let's prove that. We know how to go up to 60. Let's see. Let's skip count by 6s, or find the multiples. 6, 12, 18, 24, 30, 36, bum, 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 42 and 48, 54 and 60. So that was really cool. And then someone else said, and they didn't finish because they were trying to do something different. They said, well, that works. I'm going to try 3s. So they put their multiples of 3s. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. Or they're just adding 3 to each number. 3 plus 3 is 6. This plus 3 is 9, and so forth. So I said, oh, that's multiples of 3. But the shaded boxes, oh my gosh, I think it's multiples of 9. So let's remember, multiples are just adding 9 each time. 9 plus 9 is 18. Or you can use your skip counting songs. 9, 18, 27, 36 and 45, 54 and 63, 72, 81 and 90. So that was another pattern. So this is just a small portion of patterns that people found. There was a lot of amazing ones, and I look forward to seeing your responses also.